All right, this is it. We made it, the end of chapter 3, which is actually the end of module 1. Woo! The end of logic and Venn diagrams. We did it. So, in this one, again, we're going to be dealing with arguments. Okay, so here they are. Those same kind of arguments: statement, statement, conclusion. Okay. But in this one, if you start looking at these, notice these things are saying all clocks keep time accuracy or accurately. No spiders have 6 legs. Some funny people are professors. So here we are looking at quantitative statements and arguments. So in this one, I have provided you some notes that are called Euler diagrams. So in Euler diagrams, we're actually going to be using circles to help us determine if we have valid or invalid arguments. Okay, so these last couple problems that you will see, and there's not many, not in your homework and not on the quiz and exams. I think there's like maybe two or two or so that are on that homework quiz and exam that you'll have to be able to do with. So Euler diagrams are jumping back to quantitative statements, although these are not as bad as what we dealt with in 3.1. These are okay. I don't mind them, but we're going to be, as you can see, using circles to help us out. So a couple things that I've given you right over here. I've given you some information about certain statements. So like if you have all A are B, notice that the A circle is inside the B circle because it's all. It means everybody in here is inside the B circle, okay, is a part of B. All right. Notice that when it says no A or B, these two circles are separate. They don't like each other. They don't touch each other because they have nothing in common. Okay. Down here, where it says some A are B, that means that we're talking about the intersection. Okay. Some of these A are the same as B. There's an overlap when you see the word some. Okay. And then whenever you see something that says some A are not B, that means there's an overlap, but we're talking about those that are strictly in A. Okay. So some A are not B, that would be all these people that are not in the overlap. Now, how this works is what you're going to do is you're going to draw a diagram of the first statement. Okay. So let's go ahead and let's work these steps together as we go through it, because it's easier to work these and see what I'm talking about as we do it than instead of just me reading this to you and then be like, okay, let's do it. So the first thing says draw a diagram of statement 1. Okay. Remember, statement 1, just like what we had in 3.7, is the very first statement. So it says all writers appreciate language. So this is an all A or B. Okay. Writers is the A. Appreciate language. Language is the B. Okay. So if we draw a picture of this, because that's what it says, okay, in our notes, it says draw a diagram of statement 1. So we're going to have an all A or B situation. So it looks like this, where I'm going to call A, since A is about writers, I'm going to call this circle W. Since B is about language, I'm going to call this circle L. So all writers appreciate language. Okay? Now, let's talk about part 2. Step 2 says, draw a diagram of statement 2 on top of statement 1. Okay? We'll get to this little parenthesis part right here in a second. So we're going to take statement 2 here, and we're going to make it, we're going to incorporate it into this picture right here. Okay? So statement 2 says all poets are writers. So this is our new A, poets. This is our new B, writers. So this, since it's all, means that poets, I need a circle inside writers. Okay? Hopefully that makes sense. Because all A are B. This is a circle A inside a circle B. That means I need a circle for poets inside a circle for writers. So, kind of made my picture a little small here. Let me do something so I can kind of make it bigger. Woo! There we go. So inside my circle writers here, I need to have a circle for poets. And see how this works for this statement. All poets are writers. Okay? Now, out here I put might be more than one picture to draw. So when you're doing step 2, you need to make sure that you have a picture for all cases. Okay? So the question is there any other way that I can draw this circle of poets and still make sure that all this is valid? Okay? So in other words, what I'm asking is, can I take this circle of poets and put it right there? Would that be a valid picture? Okay? And no, that wouldn't, because right now I'm violating all poets are writers, because poets are not inside the writers. Okay? This circle poets has to be in here. Okay? Well, what if I put it like that? Okay? I put it on the edge. Is this still valid? And again, no, it's not. Because again, this says all poets are writers. Poets must be inside writers. Okay? What about this? Is that valid? And no, that's not. Because again, this last statement says all poets are writers. This circle poets has to be in here. So is there any other way I can draw this picture? No. There is no other way I can draw this picture. Okay? But just so you know, some of these, there's going to be more than one picture that you can draw. You'll see that coming up soon enough. Okay? All right, so there's step 2. There was only one picture to draw. This is what it looks like, where we take our second statement and we work it into our first picture. That's what this is all about. You're going to take that second statement and you're going to work it into that first diagram. Okay? Now, this is where we do step 3. Step 3 says it's only valid if the conclusion is true for all pictures. Okay? So we're not going to draw anything new, but we want to see, does this conclusion here, all poets appreciate language, is that valid in this picture? Okay? So again, this is another all statement. All poets, so poets is A, appreciate language. Language is B. So we need a circle of poets inside the circle of language. So is this circle poets inside the circle of language? Absolutely. This small circle of poets is surrounded by the circle of language. So therefore, we can conclude this is valid. Because this picture shows this statement 100%. All poets appreciate language. The circle poets is inside completely the circle language. Okay? That's what Euler diagrams are all about. Okay? You don't do truth statement, you don't do truth tables on this. Okay? There's no there's no chart to use on this. Okay? You have to use Euler diagrams. All right? So let's take a look at another one. I've got 4 more examples. So let's do another one. Go ahead, pause the video, give this one a shot. Go. Okay. So in this one, it says all clocks keep time accurately. Okay. So this is an all A, R, B. So our A is clocks. our B is accurate time. So in this one, again, since this is an all A or B, the A, which is clocks, is surrounded, I'm going to make my circles a little bit bigger this time, by accurate time, or what I call TA, time accuracy. Okay? And you can name your circles whatever you want. All right. So there's our first circle. Clocks surrounded by time accurately. All right. All time measuring devices keep time accurately. All time measuring devices keep time accurately. So again, this is an all A or B. So our A in this one are time measuring devices, and our B is the accurate time. So in this one, this is one of those situations where we can have more than one picture drawn. Because some of you probably did this. Took the time measuring devices, so let's call that TD, time devices, and put it inside the clocks, which is also inside time accurately. That works. Okay? Now, I'm going to draw some of these other pictures too, because I think it's going to be important that you see all of them. Well, it's not going to be important. It is important that you see all of them. So this was the original. Another way you could do this is, what if the time measuring devices surrounded the clock? And again, this still keeps everything valid, because in here, clocks is still inside the time accurately. The time devices is still inside the time accurately. Those are the two things that we have to meet. Okay? It says clocks are inside the time accurately. Time measuring devices, time devices are inside the time accurately. And again, over here, I still got that. Clocks are inside the time accurately. Oops, didn't mean to do that. And time devices are inside the time accurately. All right. But there are still other circles we could draw. Hopefully you considered that. So I've got to hide this guy because I have a feeling I'm going to need more room. So my circles kind of got smaller. Time accurately. Clocks. It could look like this. Time devices. Maybe some of you drew it like that. Okay? Because again, clocks is inside time accurately. Time devices is inside time accurately. It didn't say anything about these two having to touch or be surrounded by each other. It just says these two circles have to be inside time accurately. And then hopefully I've given you the idea of one more picture. Time accurately. Clocks. Time devices. So they could look like that. They could have overlap. This is as tough as what it gets right here. This is where you have to think like, okay, again, when you're doing this overlap, and I wish we were together in class for this because it helps me to help you make sense of this more when we're in class. All you have to do is make sure that these two pieces are met in every picture. These two have to still be valid, okay? If these two are not valid in your picture, then that's not a valid picture. You have to throw that picture out, okay? And all we had to do was make sure that clocks is inside accurate and devices is inside accurate. And in all these pictures, clocks is inside my accurate. Time devices inside my accurate. Clocks is inside the accurate. Time devices is inside the accurate. Okay? Now, it didn't say anything about clocks and time devices being able to surround each other or be inside each other or not touch. moving stuff around. Or not touching or overlapping. That's up to you. But these are the 4 pictures that depict what we have up above, making sure that these are kept in every picture. Now we just got to know, is this valid? So down here it says all clocks are time measuring devices. So this is another all A are B, where clocks is A, time devices are B. So what this means is every picture down here has to show that the circle clocks is inside time measuring devices. That's what this means. If every picture does not show that, this is invalid. Okay? So if we look at the first picture, is the circle clocks inside the time devices? And no, it's not. It does not work for this picture. This is actually the only picture that shows what we wanted. The rest of these does not show clocks inside the time devices. Okay? Since these pictures do not show that, this is invalid. Okay? You have to make sure that you check all cases, because if you only draw one case and there's more than one, you might end up showing that it is valid when it's really not. Okay? You need to make sure that you know what every possible case looks like. The most you will draw is 4 pictures. That's the most you will draw on this. This is as hard as what it gets right here. Okay? So that's why I've got more examples to try. You need to keep trying these and experimenting with these. So go ahead, pause the video, and give this one a shot. Okay. So it says all insects have 6 legs. So this is an all A or B. Insects are A. B is 6 legs. So I've got 2 circles. Insects and 6 legs. So I'm going to let this be my 6 legs and this be insects. So my insects are inside the 6 legs. All right, so this is met. Now the next one says no spiders have 6 legs. So no means that the circles for spiders and 6 legs cannot touch. Okay? So spiders and 6 legs cannot touch. So there we go. Spiders and 6 legs are not touching. But again, you need to ask yourself, is there any other way I can draw this? Well, can I have any overlap? No. Okay? And again, this is, I didn't put this up here, this is a no A R B. Okay? So again, this picture down here can't happen because I've got spiders and 6 legs touching. I can't have any over like that because spiders and 6 legs are touching. I can't shrink this down and put it entirely in here. I can't do this because that would mean that 6 legs is surrounding spiders. Spiders is in 6 legs. That can't happen. Okay? So this right here is the only picture that is valid. Or, well, not that is valid, that can be drawn. This is what it looks like. So then down here, the question is, oops, I still got that circle that's right there. This is the only picture that can be drawn. So the question is, down here, it says no spiders are insects. So no A or B. So is the circle for spiders and insects separate? Absolutely, 100%. So since this is the only picture, and it is true in this picture, this conclusion, that means this is valid. And there you go. Let's do this again. And if you want to work on this in a Zoom meeting or anything like that, please, by all means, come to a Zoom meeting. Let's talk about this. You can email me, text me, and all that stuff, so that way we can talk about this, because I know that Euler diagrams can sometimes be a little bit of a pain. And I have plenty of examples that we can work beyond these 5 examples that I'm giving you here. Okay? But if you can do these 5 examples, you should be okay for the homework, the quiz, and the test. Okay? So go ahead, pause the video, give this one a shot. All right. So in here, it says all comedians are funny people. So this is an all A or B. Okay? So we've got to circle comedians. And we've got a circle for funny people. So there's what it looks like so far. Now, next one says, some funny people are professors. Some funny people are professors. So that means, because it's some A or B, some means that there is an overlap. So funny people and professors should overlap. Okay? So one way to draw this looks like this. Professors. And there you go. Now the question is there any other way to draw this? Absolutely. There are other ways to draw this. Let's take a look at those. So this is one way. So another way, if I got funny people, comedians, what about that? Is that still okay? Do funny people and professors still overlap? Absolutely. Just now there's a little bit more overlap over here with comedians. Okay? Is there any other way to draw this? Thinking about it. And I'm going to say no, there's not. So the question then that lies before us, I'm just making sure, double checking myself. I feel like there's another way to draw this, because I cannot have professors in here, because that would be all professors are in there. Yeah, okay. Yeah, this is it. There's only 2 circles here. So the question is this valid? Some comedians are professors. So some A are B. So in both of these pictures, do comedians and professors overlap? And the answer is no. This picture right there does not work. I only have professors and funny people overlapping. It is true in this one, but because it does not work for this picture right here, we know this is invalid. Okay? Remember, in order for this to be valid, it would have had to work for everybody. Every picture drawn, it has to be true for. All right, last one. Here we go. I believe this is the last one. Yes, last one. Give this one a shot. Okay, so this one's a little different. See what you did. So it says all actors are artists. So this is an all A or B. So I've got a circle for actors, which I'll call AC. And then I got a circle for artists, which I'll call AR. Okay? Next, it says Sean Penn is an artist. So this piece right here, this is like a point. Okay? They're telling you where to put Sean Penn. Okay? So they're saying Sean Penn is an artist. So one way we could draw this picture is to put a point right here and call this SP for Sean Penn. Now, is that the only place Sean Penn can go? And the answer is no. Because again, all I have to do is make sure that Sean Penn stays in the AR circle. So another place we could put Sean Penn is right there. Because isn't the point SP inside the circle AR? Absolutely. So this is actually a point that they gave you. That's all that is. So now the final question is it true? Is this true for both pictures? In this picture right here, does it show Sean Penn is an actor? And no, it doesn't. This is the actual picture where it shows Sean Penn is an actor. But since it doesn't work for this picture over here, this is invalid. And there you go. Those are Euler diagrams. Okay? So again, this last piece that they're talking about right here, they want to know, is the point Sean Penn inside the actor circle all the time? And the answer is no. Okay? All right. So that right there wraps up chapter 3, which wraps up logic. So all of chapter 2 and chapter 3 is now yours to command. Make sure all assignments are done, all quizzes are done, and we can begin to start talking about your exam coming up. So see you then.